Hello students, welcome to Arjun Mac classes. Today we are dealing the formulation of LPP because yesterday we completed the basic details related to the LPP like introduction to operations research and introduction to LPP we completed. And again just I will make a small recap here. If I want to say the problem as a LPP, it should have three components. First one is it should have decision variables, and second one is it should have objective function, and it should have the constraints, and also it should have the whatever the decision variables are you're taking, so that should be greater than or equal to 0. Okay, so after that we just will go through the some one problem on this, so then we will understand what is the decision variable and what are the constraints here and what are the non-negativity functions. So those all things we will understand. Okay, so I will read now. A toy company manufactures two types of dolls, A and B. Each doll of type A takes twice as long to produce as one of the type B, and the company would have time to make a maximum of 2000 per day. If it produces only type, the supply of the plastic is sufficient to produce 1500 dolls per day, both A and B combined. If the company makes profit of rupees 3 and rupees 5 per doll respectively on the doll A and B, in order to maximize the profit, formulate LPP. So here we are not going for the problem, we are just formulating the problem first. Okay, so you can see here, I already told it should contain decision variables and it should contain objective function, it should contain the constraints. So we'll read the statements. You can see here the two products they are. Yes, here they given two products, and these two products are going to become our decision variables. So I written here, you can see, let this. Okay, yes, so let the type A product produced are considered as a X1, and the type B products produced are considered as a X2. So now what we done is we identified the decision variables. So those two decision variables are X1 and X2. They are taken from the two products, right? So next one is, so we have to check for the constraints. What are the constraints here? He is telling that, so for a first constraint he is mentioning we can produce around maximum of 2000 dolls per day. So it is a limit, actually maximum limit is there. So this is a maximum limit to produce per day. And another equation he given, another statement he given, so he can produce only the 1500 dolls per day, so because the raw material available is that much. So based on these two constraints we can construct two equations. The first constraint equation will become, so like this, he can read here the second line here. The type A takes twice as long as to produce as one of the type B. So means the type A product, what is the type A doll, it is taking 2 times time of the type B. Means, so the equation will be like this. So that equations will mention, so that is the constraint equations are like this. Constraint equations, the 2x1 plus x2. The constraint here is, so we can produce per day only the 2000 products, right? This is a one constraint, so I will call this as a equation 1 here. So we have another constraint here, so the raw material constraint. So the raw material is nothing but, here they are using the plastic as a raw material here. So plastic available is only way from that available plastic is to produce 1500 dolls, not more than that. So this is one more constraint, so he is taking for both the products. So then x1 plus x2 is less than equal to 1500, means we can't exceed this 1500 limit. This is our another constraint equations. So second one is, we did decision variable, we did constraint equation. So next what we have to do, we have to read the third statement here. If the company makes a profit of rupees 3 rupees and rupees 5 per doll respectively on a doll A and a doll B, in order to maximize the profit. So if it is the coming, if this problem is subjected to what? The profit, and again he is giving a statement of maximize. So maximize is going to become our objective function here. So objective function maximize the profit. So objective function will become like this: maximize z equal to 3x1 plus 5x2. This is going to become my objective function, right? So once we write this objective function and a constraint equation, at the end we have to mention the non-negativity functions here, non-negativity statements. Non-negativity constraints, it should be x1 comma x2 should be greater than or equal to 0. So this is the statement we have to mention. Once it is the statement is done, next what we have to do is we have to represent this total equations in one form. That is, the problem is subjected to the maximize z equal to 3x1 plus 5x2 subjected to constraints 2x1 plus x2 less than or equal to 2000 and x1 plus x2 less than or equal to 1500. So then next one is, so non-negativity conditions x1 comma x2 should be greater than or equal to 0. So this is our LPP. This is our last output. We have to write this total form in a one box. This is the solution. Thank you.